I will introduce the project background, data cleaning process, and data standardization. We choose the online shopping company datasite. This datasite records the information of users who are browsing web page. The purpose is to analyze the user's behavior while browsing the web to predict whether the users will eventually make a purchase. Optimizing the prediction model will develop a more effective marketing plan, enhancing the user's experience, and generating revenue for the companies. The data model optimizes logistic regression, decision tree, and neural network. First is the data cleaning part. Because this dataset contains categorical variables, there may be order or size relationship. Therefore, one-hot encoding is performed first to prevent possible orders or size relationship from affecting the model. Then the dataset is checked for missing values. The results show that there are no missing values in this dataset. The factor values are set up for what X and Y are, respectively, in this dataset. The Y that need to be predicted is whether the users made a purchase. In other words, if the company made a revenue, so that is the revenue column. When set up X, delay the revenue columns and set all the remaining columns to X. Set revenue to Y and transform the data in the revenue columns to an integer tab to make it easier to run the model subsequently. Now let's talk about how we made the dataset field. We start by storing the data of type float 64 and integer 64 in the dataset in a variable called standardized data. Then we create a standardizer, which we found called scalar, to normalize the data. Then we use the fit transformizer to fit the data in the standardized data variable, performing a normalization transformation to ensure the data was fair for our model. Next, let's see how the spatial model has been improved.
Hello everyone, I'm Di Xinjiang. Now I will introduce the logistic regression model for predicting online shopping data. First, let's discuss the advantages and disadvantages of logistic regression. It provides probability scores and determines the importance of predictors, but it is prone to overfitting with many features and it is limited to binary outcomes. In business, it's used in marketing to predict customer query and campaign response, and in finance to assess credit risk. To build the model, we split the data into a 30% test set and a 70% training set. Initially, the recovery rate for predicting revenue equal to 1 was low at 0.38, indicating a class balance issue. To address this, we use undersampling. This increased the recovery rate to 0.76 and improved the F1 score from 0.50 to 0.63. Although precision dropped from 0.75 to 0.53, and overall accuracy slightly declined from 0.88 to 0.85. The model's performance on the miniature class improved significantly. And then the ROC crew and AOC score for the validate our improvements. The AOC score is 0.90, demonstrating strong classification ability. The ROC crew indicates that the model can achieve a higher true positive rate with a lower false positive rate. Last, using L2 regularization with Z equal to 1, we evaluated the model's stability. The course validation AOC scores range from 0.91 to 0.94, which with an average AOC of 0.9331, reflection excellent consistency and performance in demonstrating positive and negative samples. Well, there were some differences between folds. The model's overall high AOC values indicate robust classification capabilities. This is the end of my part. Next, my teammate will analyze the decision tree model.
Decision tree is a supervised machine learning algorithm for classification and regression tasks. It constructs a tree model by progressively dividing a dataset into smaller subsets by making a series of true or false decisions on the data feature. Decision tree models are intuitive and easy to interpret and are well suited for dealing with complex nonlinear relationships. However, decision tree models also have some disadvantages, such as a tendency to overfit the training data, resulting in poor performance on the test set. They are also highly sensitive to noise and variation in the data, leading to significant changes in the tree structure. Well, the key metrics for evaluating the model include mean squared error and coefficient of determination. These metrics help us quantify the performance of the model and understand how well the model fits. A lower MISE indicates more accurate predictions, while an R-square value closer to 1 signifies stronger explanatory power of the model. Feature importance analysis can help us understand which features have a greater impact on the model's prediction. The feature importance analysis of the decision tree model shows that page values, bonus rate, and loss number are the top 3 important features that have a significant impact on predicting users' consumer behavior. To improve the performance of the decision tree model, we employ the random forest model. Random forest is an ensemble learning method that improves the accuracy and stability of the model by constructing multiple decision trees and combining the prediction. The advantages of the model include reducing overfitting and handling high-dimensional data. However, random forest models have higher computational complexity, longer training time, and higher memory consumption. The training and evaluation result shows that the improved random forest model outperforms the original decision tree model in all metrics. Decision demonstrating its advantages and effectiveness in handling complex data. In terms of business insight, similar to decision tree model, page value, bonus rate, and loss number remain the most important feature. The random forest model further confirms the importance of this feature and provides more accurate prediction results, helping us to better understand users' buying behavior. Now, moving to the next part, neural network model.
Hi, this is Cassie. Today, I will present the improvements and the results of our neural network model for predicting revenue. We will discuss the strengths and the weaknesses of the neural network, the enhancements we've implemented, their impact, and the commercial insights derived from the model. Neural networks capture complex patterns in data due to their flexible architectural and nonlinear transformation capabilities. They excel in handling large volumes of data and learning intricate relationships. However, neural networks also have drawbacks, such as limited interpretability, high computational requirements, and a tendency to overfit. In our previous iteration, the model had significant overfitting issues. To address this, we implemented several key enhancements. The first one is the early stopping. By monitoring the validation loss and stopping the training process early, we prevented the model from overfitting. The second one is dropout layers. These were added to mitigate overfitting by randomly dropping neurons during training, forcing the network to generalize better. The last one is the hyperparameter tuning. We conducted an extensive great search on hyperparameters like batch size, learning rate, and the number of neurons to find the optimal configuration. These improvements led to noticeable performance gains. The mean square error is 0.0871, indicating the average of the square differences between predicted and actual values. The mean absolute error is 0.1823, showing the average absolute differences. The R-squared score is 0.3732, indicating that the model explains approximately 37.32% of the variance in the target variable. In conclusion, the neural network model, with its improved performance and reliability, aligns well with our business goals of enhancing operational efficiency and strategic foresight. This model will provide valuable insights and support the business team in making more informed and impactful decisions. That's all from my side. Thank you for your attention. Let's move on to next part.
Our model enhancements significantly improve data preprocessing, model configuration, and performance evaluation. By using standard scalar for feature scaling and random oversampler to address data imbalance, we will ensure model stability and better learning of minority classes. The hyperparameters of each model were fine-tuned using grid search CV, providing a more optimized configuration compared to default settings. We've also expanded our model section by adding logistic regression, decision tree, and narrow network models, allowing for a richer compression of performance. Regularization was incorporated into the logistic regression model to prevent overfitting, and comprehensive one-hot encoding of all categorical variables was implemented to enhance future treatment. Detailed evaluations using confusion matrix and classification report now provide more insightful performance matrix beyond simple accuracy. These technical improvements translate into substantial business benefits. They enhance the model accurately segments customer groups, identifiers high value and potential churn customers, and supports personalized marketing strategies to boost loyalty and reduce churn. It helps optimize product lines and service quality by identifying customer performance, improving inventory turnover and satisfaction. By predicting customer behavior and demand, we can allocate sales resources more effectively, enhance sales efficiency, and exclude precise cross-selling and upselling strategies, increasing customer lifetime value. Furthermore, the Model S in early identification of at-risk customers for preventive measures, optimizing resource allocation to reduce operational costs, and predicting market trends for strategical planning and product development. Data visualization tools such as cluster analysis and rider plots effectively demonstrated these insights, showcasing the model's practical applications and contributions to business growth. Here, we present the performance comprehension of the 4 models. As we can see, each model has its own strategies and weaknesses across the different matrix. Upon closer analysis, we observe that the random forest model has the lowest mean square error, indicating the smallest average squared error among the models. It also has the lowest mean absolute error, which shows the highest accuracy in predictions. Additionally, the random forest model has the highest R-square source, meaning it explains approximately 44.53% of the variance in the data. These results highlight the superior performance of the random forest model. In conclusion, the random forest model outperforms the other models across all metrics, making it the best choice for our dataset. Its ability to provide accurate and reliable predictions is evident from its performance matrix. The best parameters for the random forest model are the max feature, which is squared, and in estimators is 100. So that's all for our presentations, and thank you. Thank you for listening.